Good morning, everybody. Today we're going to finish up chapter 3 and start chapter 4. Chapter 3, section 5 deals with solving equations and inequalities that have absolute values. Absolute values look like this, equals some number A. Now, what absolute values define a distance between 2 points or between two numbers. So between a number and 0. You have to have a starting point between a number and 0. In other words, if we're right here, and there's Dallas, and here's Fort Worth. Let's say we're halfway between there, and there's 12 miles in between the two of them. It doesn't matter which direction you go, you still have 12 miles to go. This one isn't positive, this one isn't negative. It's just a value. That's how absolute values work. So let's look at some examples. The absolute value of 3 is 3. The absolute value of -3 is 3. Why is that? Remember, it's a distance from 0 to a number. All right. So if I ask you, starting at 0, how far is it to this number? You'd go 1, 2, 3. 3 spaces. Likewise here, 1, 2, 3. 3 spaces. This is the absolute value. This is the absolute value. So there is no positive or negative. If it's inside there, it wipes it out. Okay. Only of values. In other words, if I had x minus 3, that does not equal the same thing as x plus 3. No. It's only a value. If you have an equation in there, then you have to work it out. And then at the very end, that's when you get rid of the absolute value. Okay, so absolute value of 3 is 3. How about absolute value of -3? Order of operations. The absolute value of 3 is 3, and the negative front. So the answer is -3, because the negative's outside. You cannot distribute. Inside absolute values. So with this one here, we'd have to take the inside of this first. So absolute value of -3 is 3, and bring this one down. So the answer is -3. So that's how it works. Now, the absolute value of a variable. If I said the absolute value of x is equal to 5, what can x equal? Remember, if here's my 0, and I'm going 5 spaces, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it can be a positive or a negative. So the x can equal a positive or a negative 5. So that's the rule. Whenever you drop the absolute value, when you drop the absolute value of a variable, the answer becomes plus or minus whatever the number is. Whatever the number is. It also works when you have equations. Since we can't go any further, we isolated the absolute value sign. When we drop the absolute value, we got a plus or minus answer. So now this question, we're solving for x. X plus 3 equals negative 5, and x plus 3 equals positive 5. So you solve them both. So x equals negative 8, or x equals 2. And we can check it. Negative 8 plus 3, absolute value. Negative 8 plus 3 is negative 5. Absolute value is 5. 2 plus 3 equals 5. Drop the absolute value sign, and there you have it. So it's very important. Whenever you drop the absolute value sign, you have to put a plus or minus, because the distance is the same both directions. So that's how it works whenever you, well, let's look at an example. That's how it works when you have equal signs, when you're doing equations. All right. So again, we have to isolate the absolute value sign. So we have to get rid of anything plus or minus. Here's a plus, so it's positive 4. Get rid of it with a negative 4. Five minus 4 is 1. Change the signs. X plus 2 equals negative 1. Divide by 3. This one has no solution. Because an absolute value of x cannot equal a negative number. So if you have an absolute value at the very end equals a negative number, there's no solution, because no matter what you put in there, when you take the absolute value of it, it'll never equal negative. This one. X minus 3 minus 1 equals 4. isolate the absolute value first. So we get rid of the -1, so we add 1 to both sides. Four plus 1 is 5. We got the absolute value isolated, so we can drop the absolute value. When you drop the absolute value, you have to put a plus or minus in front of the answer. This is the negative side, this is the positive side. So we have x minus 3 equals -5. X minus 3 equals +5. We have to solve both of those equations. So we add 3 to both sides. We add 3 to both sides. Five is bigger than 3, so the answer is negative. 5 minus 3 is 2. 5 plus 3 is 8. Again, whenever we have this, we always have to check your answers. Check your answers. So we have absolute value of x minus 3 minus 1 equals 4. X minus 3 minus 1 equals 4. So when x is -2, -2 minus 3 minus 1. -2 minus 3, they're both negative, so the answer is -5. Absolute value of -5 is just 5. 5 minus 1 is 4. So -2 is a good answer. Likewise now with 8. 8 minus 3 minus 1 equals 4. 8 minus 3 is 5. The absolute value of 5 is 5. Minus 1. 5 minus 1 is 4. So these are both correct answers. So that does it for equal signs. We do it the same way, but you have to isolate the x value of the absolute value sign. Once you do that, then drop it, isolate the value, drop the absolute value sign, and place a plus minus in front of the answer. Solve both positive and negative equations. Those are the steps. All right, now inequalities. Absolute value with inequalities. The same rule applies on the graph. It's open circle if it's just strict inequality. It's a closed circle if it's less than or greater than equal to. Let's look what the absolute value of x being greater than a number, let's say 3. Let's look at the formula for this. As I said earlier, the absolute value represents a distance from 0. What I'm saying here is this is strictly greater than, so it's an open circle at 3, and it's greater than 3. So it's going away from 0. So we do the same thing on the other side. At -3, because when we drop the absolute value sign, one side's greater than +3, but the other side has to be less than -3, because it has to go away from 0. So for example, give me a number that's bigger than 3, 4, 5, 6. Likewise, if I put -4 in there, absolute value of -4 is 4. 4 is bigger than 3. -5 is bigger than 3. And absolute value of -6. So if it's greater than, it's going opposite directions. If it's less than a number, okay, since x and 3 are the numbers, so it's an open circle there, open circle there. And if x is less than 3, that means it's going towards 0. That means it has to go towards 0 from the other side also. Just give me a number that's smaller than 3, 1. But so if I put -1 in there, the absolute value of -1 is 1, and that's less than 3. So if it's less than, what that means is that it's bigger than the negative number, but it's less than the positive number. It's between there. So these are the formulas. If we have a less than, after isolate the absolute value, if we have a less than a number, when we drop the absolute value sign, it's going to be less than positive A, but it's going to be greater than negative A. If it's greater than, or it's going to be less than the negative. What's happening here is this. Without stating so, it's defining the negative values of x. Whenever you drop the absolute value of negative x is x, but there's a negative in front. Whenever we change the sign of x from negative to positive, we have to change everything, which includes the inequality. So the x inside here can be positive or negative. What this says is the x, the number inside here, if x is less than 3. What this one says is x can be positive or negative. If we set that equal to 3. X can be equal to positive or negative 3. So we have x is less than 3, negative x is less than 3. Change the sign, change everything. So we have x is greater than negative 3. X is greater than negative 3. X is less than 3. So there we have it. That's how it works. Let's take some examples. 3x plus 2 is less than 5. The absolute value is isolated, so we can drop the absolute value. But when we drop the absolute value of it, it's going to be negative 3x plus 2 is less than 5, and positive 3x plus 2 is less than 5. Change the signs. 3x plus 2 is greater than negative 5. 3x plus 2 is less than 5. We have 3x plus 2. It's greater than negative 5, but it's less than 5. And we do what we did inequalities in chapter 1. Solve the middle. So we have subtract 2 from everywhere. Negative 5 minus 2, they're both negative, so add the numbers. 5 minus 2 is 3. And then get our x by itself, divided by 3 everywhere. Negative 7 over 3 is less than x is less than 1. And there's your answer. And you still have to remember how to convert to set notations and graphing. In set notations, since it's an equality, it's not equal to, so it goes from negative 7 over 3 to 1. Or it goes back. So here's the formula. Absolute value of an equation, this is an equation with x is less than n. Because it's less than, we could just do it that way. In other words, once I show you the formula, instead of going through the long way we just did up here, we could just take in the answer. So this is my A. That's inside the absolute value. So I put it between my absolute values. On the left-hand side, it's negative, the number. On the right-hand side, it's the number. It's just much faster doing that. Conversely, if we had a greater than sign, That's going to be a is less than negative n, or a is greater than positive n. Let's do that plus first. Again, whatever's inside the absolute value sign is the a. If it's greater than or greater than equal to, then we use this formula. So we have 5 plus 2x is less than negative 1, or 5 plus 2x is greater than positive 1. That's what this thing says. And now we solve. Subtract 5 across the board. Two x is less than negative 6, or 2x is greater than negative 4. Because 5 is bigger, the answer is negative. Divide by 2. X is less than 6 divided by 2 is 3. Or x is greater than negative 4 divided by 2 is 2. If we look at the graph of this, well, it's equal to, there's equal to sign underneath there, because it's a greater than equal to. Which means they're solid circles. X is less than or equal to negative 3, so it's this way, all the way to negative infinity. X is bigger than or equal to positive or negative 2. It's this way to positive infinity. So it's negative infinity to negative 3, union, bracket, because it's closed. Negative 2 to positive infinity. Again, if you don't remember your inequalities, review those, because you'll need those for the tests. And that's end of chapter 5. Or chapter 3, I mean. Section 5, chapter 3. So let's start chapter 4. Now we're going to start building up to bigger equations, bigger what are called polynomials. Chapter 4 deals with polynomial functions and models. All that means is how we can use it in the real world. No, this is section 1, sorry. Because chapter 4 deals with polynomial functions. Because now is when we're going to start really look at, we've been stuck with small equations, linear equations, quadratic equations, absolute values, square roots. Now, a polynomial. Well, let's look at this. A monomial, mono means one, so it has an equation with one term. Those are each examples of monomials, single terms. Binomials. Bi means two, so it has two terms. 3x plus 2 or negative 5x to the 7th plus 3x. It could be anything. As long as you only have two terms. They could look like anything. A trinomial has three terms. That's an example of a trinomial. A quadratic equation. A binomial example is a linear equation, mx plus b. A monomial is an example of a constant or a single term. A quadrinomial has four terms. It has four terms. And so on and so forth. That just tells you how many terms you have. We also have something called the degree of a polynomial. Oh, I never defined what polynomials were. Poly means many. So it's an equation with many terms. Since many is an ambiguous term in itself, all of these are examples of polynomials. So a polynomial, we'll write it like this. It's a function. It's a function with variable x. It's a to the a sub n x to the power n. It's easier this way for us. Plus a plus u. A n minus a sub n minus 1 to x n minus 1. A sub n minus 2 times x n minus 2 dot 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 a2 x2 a1 x1 and a0. That's a general form of a polynomial. N could be any number. For example, here we have an example. You notice how they go down in size. Whenever you have a polynomial, always put your exponents in decreasing order. The exponents of x are in decreasing order. That's important because on the very far left should be the largest exponent. And the very far right should be the constant. That's what it always should be set up that way. I mean, if there's no constant, then you'll have just a value with the smallest value of x. Once you set it up this way, this first term is called the leading term. The leading term is important. It has the highest exponent. This number here, the number in front of the x, is called the leading coefficient. The n, the largest exponent, is called the degree of the polynomial. Because all this stuff, the leading term tells us a lot. I've talked about this a couple of times. Let's see. Okay. What's the leading term there? Five. It's the only term. It's a leading term. It's a monomial. What's the degree? Is there an x? No x. So the degree is 0. So if the degree is 0, we have a constant. How about this one? Also, since this is the largest number, it's actually the leading coefficient. It tells us if it's a constant, is it above or below the x-axis? Is it positive or negative? It's positive. So it's above the x-axis. How about this one? What's the degree of this one? Let's look at it again. Where's the degree? The degree is the exponent. Is there an exponent up there? If it's nothing there, it's invisible 1. Because it has to be, because remember, the exponents tell us how many x's do we have? We only have one x in this equation. So since the degree is 1, this is a linear equation. Is it increasing or decreasing? In other words, does it go like this or does it go like this? It's increasing. Why? Because 3, the leading term, leading coefficient is positive. It's increasing because A is positive. If A was negative, it would be decreasing. How about this equation? What's the degree here? The degree is 2. Since it's 2, it's a quadratic equation. So what does the leading coefficient tell us? The leading coefficient is -4. It's less than 0. So what does that tell me about the graph? It opens down. Because it's quadratic, it's a curve. Since it's negative, it opens down. What's the degree here? Since it's degree 3, it's a cubic equation. And the leading coefficient is what? +5. It's greater than 0. So cubic equations look like this. Since A is positive. If A was negative, it would be decreasing. That's if A was negative. We'll do one more. We'll do quartic. We'll call it quartic equations. The degree is 4. We call that a quartic equation. The leading coefficient is, which is greater than 0. So since it's degree 4 and it's a positive leading coefficient, our equation will look like this. It's an increasing equation. Both ends go up. I talked about this about a month ago. These are called end behaviors, which both ends of the graph point a direction. End behavior. If n is even, both ends point in the same direction. Up, if your leading coefficient, is positive. Down, if the leading coefficient is negative. If n is odd, both ends point in opposite directions. Right side goes up if the leading coefficient is positive. It looks like this. And right side goes down if A is negative. So we've described polynomials. Here are some properties of polynomials. Polynomials are smooth and continuous. What does that mean? What does smooth and continuous mean to you? It has slope, but it's no points, no sharp edges. So it's got to be continuous also. There can't be any breaks. So no points, no holes, no sharp corners. This is the absolute value of x. It's not a polynomial because it's got a point. If it has a hole, it's not a polynomial. Or if it has a jump discontinuity, it's not a polynomial. So far, so good? Because our goal for this chapter is I can give you any size polynomial like this. You'll be able to graph it. That's the goal for this chapter. So let me put some examples up here. Because in order to graph a polynomial, we need certain points. The y-intercept, the x-intercepts, the zeros or solutions. And we're going to find out that these are the same things. They're just written differently. What's the y-intercept? How do we know the y-intercept of a function, of a polynomial? What's the y-intercept of that equation? Y. Yeah. If you set x equal to 0, because the y-intercept is where x is 0. If you set x equals 0, so the constant is always your y-intercept. Always. It's always going to be and always will be. Then when we're drawing polynomials, we have to find the maximum and or minimums the highest or the lowest points. Remember, the maximum are the highest points, the minimums are the lowest points. We also have to know the domain and the range of the function, of the polynomial. Here's an example. Find me the solutions. Find me the x-intercepts. Find me the zeros of this equation. How would you do it? How have we done it in the past? And see, can we factor it? If we can't factor it, then we use either the complete the square or the quadratic formula. Why? Because that's a quadratic equation. We just spent an entire chapter talking about those. So x goes in there. What signs go in there? Because the second sign is negative, they're opposite signs. The bigger number gets the negative. I can tell who didn't do their homework. What times what is 3? When you subtract them, you get 2. 1 times 3. So the 3 gets the negative. Set those equal to 0. I got x equals -1 and x equals 3. Those are my x-intercepts. These are actually called my zeros. My x-intercepts are at -1, 0, 3, 0. In this chapter, I'm also going to show you other ways of solving quadratic equations or equations in general. What if I gave you this equation? Find me the x-intercepts there, or find me the zeros. Is it linear? Let me ask again. Is it linear? No, because it has an exponent. It can't be. So what kind of equation is it? What's the degree? Look what in your notes are. If degree is 2, what kind of equation is it? Quadratic. Very good. So we know the shape of it. And to solve quadratic equations, what do you have to do? To solve quadratic equations, you have to set it equal to 0. And solve for x. If you see it already, we could do the difference of 2 squares. If not, then solve for x. Since you only have one x in there, solve for x. Add 4 to both sides. So we have x squared equals +4. Square root both sides. Those cancel, so we have x equals what? I know you. What's that? Whenever you square root something squared, you have to put a plus or minus in front of the answer. So that's the answer. So our x-intercepts are at -2, 0, or 2, 0, and 2, 0. Those are x-intercepts. What's the difference between this equation and this equation? They're both binomials. So what's the difference? Only one term has an x here. Both terms have x's here. When only one term has an x, you can split them up. Put numbers on one side, x on the others. But if you have x's on both of them, what do they both have in common? They have an x. So if I take out one x from both of those, I got x minus 4. So I set them both equal to 0. So these are my x-intercepts. This is called factoring. Since they both have something in common, you can factor it out. We could get the same answer. 4 is made up of 2 times 2. So it's the difference of 2 squared terms. It's x plus x minus 2. That's called the difference of 2 squares. Again, we talked about that weeks ago. Whenever you have a squared minus b squared, it's a plus b, a minus b. Difference of 2 squares. So we looked at, if we had trinomials, we can see about factoring it or using quadratic formula. If we have 2 terms, we have binomials, what can we do? Let's look at quadrinomials. If you have 4 terms, before we try anything fancy, let's try something called grouping. In grouping, place parentheses around the first 2 numbers and the second 2 numbers. So we have x cubed plus 2x squared minus 4x minus 12. If the middle sign is negative, place it inside the parenthesis. If it was a plus, it wouldn't matter. We'd leave the plus outside because it doesn't change anything. Now factor both parentheses. So what do the first ones have in common? How many of them? They both have at least two x's. So we can take out two x's. If we take away 2x here, we only have one left. If we take away 2x there, we only have two. Now, what does the second one have in common? Because the leading term is negative inside here, we're going to factor out a negative, which means whatever's inside the parentheses will change signs because we took out the negatives. So what do 4 and 12 have in common? They both have a 4 in common. Whenever you divide by it, so we took out the negative, so 4 to 4, so we have x. Took out the negative, so it's now positive. 12 divided by 4 is 3. This should have been a 3. This one should have been a 3. Because for right now, we'll keep it simple. Because this parenthesis and this parenthesis have to be the same. We'll get to this equation with a 2 in there in about 2 sections. Because now we only have 2 terms here now. What do both of those terms have in common? They both have an x plus 3. So take what they have in common out, and whatever's left goes inside their own parentheses. In other words, the coefficients go inside their own parentheses. X squared minus 4. Yes. Because since this is a leading term is negative, when we have a parentheses, we always want this one to be positive. So we took out the negative. When we took out the negative, we divide both sides by a negative. And that means it changes the signs. Go ahead one more time. Right. Well, the 4's cancel. There's 1 in front of the x. We took out the negative and the 4, leaving just x. We took out the negative. 12 is 4 times. We took out the negative and the 4, leaving just 3. Yeah, so whenever this one's that's why whenever it's negative, it's a different story. Because once you take out the negative, both signs inside here change. Now we're not done yet because this one is a difference of 2 squares. X squared minus 2 squared. So it makes it x plus 2, x minus 2. set it equal to 0. So our x-intercepts are going to be where? -3, -2, +2. So at -3, -2, and +2. We also know what's our y-intercept. What's our y-intercept? -12. So our y-intercept is going to be way down here somewhere. What's the end behavior going to look like? It's cubic. So what about the end behavior? What's that going to look like? If the degree is 3, it's odd. What does end behavior look like? Do they go same direction or opposite? Opposite direction. Does it go to the right, up, or down? No, the leading coefficient is 1. It's positive. So we know this, that the right side is going to go up, the left side is going to go down. It's going to cross at 12 somewhere. So the graph will look something like this. Once we know the end behavior, we know at the very ends, either they're both going to go up, go down, or bless you. So, and also, we're going to know something else. It's called multiplicity. All of these exponents on these answers are 1. They're odd. If they're odd, that means the line crosses at those points. If I had an answer like this, if my answer was this, what's the degree of this equation? There's 1 here, there's 2 there, so 1 plus 2 equals 3. Remember this one? The degree was 3, right? 1 plus 1 plus 1 equals 3. So the exponents of our answers also tell us what's going to graphically look like. If they're all odd, that means the line is going to cross the x-axis. In this one, the degree is 3. The leading term was positive, so it's down here, up here. The multiplicity is odd on this first one, so it crosses. But it's even here, so all it does is bounce. The graph is like this. Some more examples here. If I gave you a polynomial, if the answers were like this, what's the degree? There's 3 there, right? There's 2 there. What's this one? If there's no number, it's automatically a 1. 4 plus 4 is 8, plus 2 is 10. So if it's degree 10, what do we know the graph's going to look like? What's the end behavior going to look like? They point same direction or opposite? If it's even, both end behaviors point the same direction. If the degree is even, points the same direction, either up or down. And since all the x's are positive, it's going to point up. So where are my x-intercepts? Where is this one going to be? At 4. This one, -1. This one, and this one. Remember, it's always the opposite side of parentheses. The degree is 10, so both ends point the same direction. They both point up. Remember, if the exponent is odd, it crosses. If it's even, it bounces. So what does it do at -3? Does it bounce or touch or cross? At -3, this one. It bounces, so we know it bounces there. What does it do at -1? It's an odd, so it crosses. Because if the exponent is odd, it crosses at that point. If it's even, it bounces at that point. No. It's the degree of that parenthesis. What's going to happen at 4? Is it going to cross or bounce? At 4, it's odd, so it has to cross because it's odd. Odd crosses, even bounce. Because at 5, it has to bounce. So there's our graph. It looks something like that. I'll give you another one of those. So the first thing you have to do is figure out the degree. What's the degree of this equation? Since it's 15 and all of the x's are positive, that means the coefficients a is positive. So what does that tell us about the end behavior? What's that? Odd, it goes opposite directions. I'll give you that. It's called the I'll call it the degree test, but I'll show you how that works. Since its degree is odd, we know both ends point opposite directions. Since a is positive, since all the coefficients are positive, it points up. This side points up. That means just point down. Where is this one? So what are my intercepts? Where's this one? at 0. Take each of these and set them equal to 0. And do that the rest of them. So this one, since it's an x by itself, it's here in the middle. This one's going to be at +2. This one's at -3. +4. -5. That's the easy part. We also know since the degree is 15, that means the left side goes down, the right side goes up. So what happens at -3? Does it cross or bounce? Yeah, at -3, it's odd, so it crosses. What does it do at 0? At 0, it's odd also, so it crosses. At 2, it's even, so it bounces. And at 4, at -5, it bounces because it's even. And it crosses at -3. It crosses at 0. It bounces off 2, and so -5, -3. So both ends are opposite directions. It bounces off 5, crosses at 3, crosses at 0, bounces, and crosses. So now we have a shape of our graph. Let's see. R2 and -5 zeros of this polynomial. R2 and -5 zeros of that polynomial. Besides staring at it, what would you do? What's that? What does zeros mean? It says, are these numbers zeros of this polynomial? If you plug them in, what should happen? What do you think would happen if it's called a zero? It'll equal 0. If you plug these numbers, if they're zeros, if they're solutions, and you plug them in there, then the equation equals 0. If it doesn't, then it's not a 0. It's not an x-intercept. So you have to do that and that. You have to do them both and see what happens. Two cubed is 8. 2 squared is 4. Negative times positive is negative. 7 times 2 is 34. 27 minus 34 equals -7. No. -2 is not a zero, or +2 is not a zero. But -5. -5 times -5 is 25 times 5 is -125. -5 squared is 25. 17 times 5 is 85 plus 15. 10. 110 plus 15 is 125. Yes. So -5 is a zero. Whenever it asks you, is it a zero, plug it in there and it should equal zero. If it doesn't, it's not a zero. And actually, you've been doing this already. Find me the zeros. So what are the zeros? Well, set this one equal. This is also an equation. Set it equal to zero. 5x equals 0 divided by 5, x equals 0. If it's just an x by itself, it's 0. It only changes if there's a plus or minus. So notice how many zeros we have. We have 4. What's the degree of this equation? One, two, three, 4. The degree tells us how many solutions we're supposed to have. Even though these are both the same, we only have 3. So the degree tells us how many answers we're supposed to have at the end of the thing. I got you. We have, actually, we'll do one more grouping. X cubed minus 2x squared minus 9x plus 18. Find me the x-intercepts and sketch the graph. Remember, since the middle term is negative, you have to include it in the parentheses. Did you get this far so far? So what do they have in common in the first one? How many of them? No. This one is X, X, X. This one's X, X. So how many do they both have in common? Two X's. So I can take out two X's. If I took away two X's here, how many do I have left? I took out two X's here, I just have the two. Now, since it's a negative here, I take out the negative. What else do they have in common? They both have a 9 in common. So divide both sides by both of these numbers by -9. That becomes a positive. The 9s are gone, so we have X. Positive divided by negative is negative. 18 divided by 9 is 2. Now, what do they have in common? Yep, these two terms both have an X minus 2. That means the coefficients of those go inside their own parenthesis. We have X squared minus 9. Factor this one out. X squared minus 9 is made up of what? What's 9 made up of? 3 times 3, 3 squared. Yeah, 9 times 1 go away. But 3 times 8. What we're looking for is whenever you have a minus sign here and the first term is squared, see if the second number is squared also. Not 4, 9, 25, 16, 36, any perfect squared numbers. Because if that's the case, then we have an X plus 3, X minus 3, the difference of two squares. The degree is still 3. That's the same as the original equation is 3. So what are my intercepts? And the degree was what? 3. And since the leading term is positive, what does that tell me about the end behavior? Yeah, one side goes up and the other side goes down. It goes up to the right. So we know out of this one it goes up, and out of this one it goes down. And since they're all odd exponents on the answers, they cross or bounce. They cross. So this one crosses. It crosses also at positive 18, which is the y-intercept. So there's our graph. I mean, we of course get better numbers, but that's the sketch what it's going to look like. So like I said earlier, when you got confused about the directions, let me see what's. Yeah, I talked about everything else. Is here. Think of this chart here. If A is positive, or if A is negative, if the degree n is odd, or the degree is even, if the degree is odd and A is positive, that means our graph will look something like this. So if it's odd, it points opposite direction. This is just the end of behavior chart. So if it's an odd degree and A is positive, it goes up to the right, left, down. If it's A is negative, it goes down to the right, up to the left. If the degree is even, both ends point up. If it's odd, both ends point down. So there's your chart. And the middle part, that's where we solve for the x's and see what happens whether it crosses or bounces. All right, that's it for section 4.1. We'll do some more problems next time, and then we'll do 4.2. If you want to take pictures of these, you guys come up here and take pictures of them. And I'm sorry for starting before we all get here. It's that there's some people sometimes